Terry Sparkin from the Advanced Carbons Council. I'm the executive director and founder of the Graphene Council and now the Advanced Carbons Council. And we're very happy to host this webinar on the use of graphene enhanced coatings and some real world examples presented by our partners, Petronas Advanced Materials. And with that, Dilly, I'd like you to go ahead and start your presentation. We have Dilly from Petronas. Again, they've been members with us for quite a while, and we enjoy working with them. And what I'm very excited about is this will give you some real-life case studies and applications of how graphene is being used in coatings to protect infrastructure and assets. And with that, Dilly, thank you. Looking forward to your presentation.
Thank you, Terence, and good morning, good afternoon, good evening to everyone who's joining in this webinar. Brief introduction, I'm Dilly, short for Delisa, Head of Advanced Materials. Been looking after this portfolio for the past 3 years. And graphene in itself has gone through a very interesting journey from what we thought was just a material in theory to today going into the market with our partners and friends like Kossan Paint and Transocean, who are here with me to also talk about this technology. So very quickly, my sharing is going to be focused on coatings, but what I will do for the benefit of all the members who have joined in today is, now before I go in, can everyone see my presentation? Is there any technical glitch? If there is, let me know.
You're all good, Dilly. Thank you.
Perfect. Thank you. So what I'm going to do is give a little bit of introduction to graphene very quickly, and then about Petronas Advanced Materials. What do we do? What do we have in our portfolio? And our solutions towards meeting industry challenges. Why? In Petronas, we are always customer facing, and we try and understand what the pain points are from our customers before we design any solutions. So a lot of what we do over here is designed primarily to address the industry challenges. And then we will double click on ProShield Plus, graphene coating solutions, what it does in the coating system, and the actual applications that we have today. Before I pass the baton over to my Transocean colleagues to then talk about what their observation has been when incorporating graphene into the paint system. So a little bit about graphene. Well, as most of you would know, it has always been dubbed as the wonder material with enhanced properties, be it strength, flexibility, conductivity, the list is just endless. To us, graphene is a solution, and it is designed to improve or enhance performance or reliability of its host materials. And through that enhanced performance, it saves money, especially when you look at it from a life cycle or total cost of ownership, where it comes together with the benefits of less maintenance and replacements required. And it has versatile applications that runs across multiple industries, and coating is just one of the few. In Petronas Advanced Materials, here our intent is really to advance tomorrow's materials towards a sustainable world and to improve the quality of life. And in our offerings, we have 3 different verticals. We've got ProShield Plus for the coating industry, ProCharge Plus for the battery, and ProTough Plus for the composite. And in all of these, ProShield Plus is designed to address the most fundamental pain point of the coating industry, which is corrosion. Now, before we started into this venture, with coating being our first solution to be deployed, what we did is we cast the net wide and asked about 150 over asset users out there. And the echoing concern from everyone was corrosion. Everyone was battling with corrosion, and any solution that addresses corrosion was something that was welcomed by the industry. Now, why corrosion was a big pain point is corrosion naturally comes or entails with frequent repainting, and the cost of repainting can be very, very high. Now, very specifically, coming from Petronas, we have more than 120 over assets just spread out across Malaysia. Now, if you're talking about offshore assets, the cost to repaint, it's mobilizing resources, mobilizing consumables, mobilizing tools to the offshore assets can cost lots and lots of it can cost a lot of money, and it can cause the OPEX to balloon up. So just right there, we knew we had a solution to address the pain points. And what ProShield did was, using graphene technology, it was designed to create additional water barrier properties. Now, with those additional layers of resistance or tortuous parts that we have introduced, we saw improvement in higher water barrier properties. We saw better adhesion qualities, and we also saw better abrasion resistance. And what that really meant was we were now able to extend that service life of our coating. Now, this is perhaps the most advanced solution that we have, ProShield Plus, but Petronas Advanced Materials is not just designed for one solution. We have a portfolio of solutions, and what we're working on in the background is also our solution for the lithium-ion battery, which we call ProCharge Plus, and it serves a purpose as a conductive ink on the cathode that is designed to extend the service life of the battery and have better thermal stability. And concurrently, we also have our solution called ProTough Plus that is designed for the composite segment, particularly carbon fiber, where it promotes improved tensile and mechanical and flexural strength with lesser usage of carbon fiber. But of course, today's sharing is primarily on coating, so I'm going to double click on coating here. So ProShield Plus. What is ProShield Plus? It's our master batch of formulated graphene designed to enhance liquid coating for structural and pipeline coating applications. So this is what we have. It is a formulated graphene additive for protective coating applications. Again, pain points. What we're really trying to address here is corrosion, effectively prolonging the effects of corrosion to the metal substrate, and with that, reducing the amount of repainting, which comes with at a high cost. From a technology angle or from the science angle, what we're really doing essentially is creating layers of resistance that slows down the permeation of water and oxygen to the metal substrate. So what it does, it creates additional barriers that slows down corroding agents from reaching the steel surface. And with that, we're able to extend by 2 times, if not 3 times, against corrosion. So since we started ProShield Plus, of course, the focus at that time when we went into the market was primarily targeting the oil and gas segment, which, as you would know, has the most extreme corrosive environment. But even within these areas, we were looking very specifically at atmospheric zone, our solution designed for the atmospheric zone, and this would be our standard tolerance epoxy. Now, this is suitable for steel structures, equipment, and piping for onshore and top deck offshore. It carries 2x corrosion resistance and 2x, and it also comes with double or longer 2x longer warranty in comparison to a non-graphene paint. You can even apply it on sweating pipe or damp surface. And the most interesting part that seems to be gaining traction among our asset users is that it requires simpler surface preparation. One of the biggest challenge that the team has is the fact that in an oil and gas environment, you would have to do extensive surface preparation before you paint any system on the metal or steel substrate. But with graphene in it, and the fact that graphene has better adhesion quality, we can now look at or explore the possibility of having simpler surface prep, and that makes application a lot more easier and exciting, and not to mention more effective and productive. We also have our solution for the splash zone, the boat landing space. Now, this is even more corrosive than atmospheric zone because it's half submerged in the seawater. And this will be areas like your boat landing, jacket leg, hull, and fender. Just like the atmospheric zone, it carries additional corrosion resistance by 2x, and it also comes with double the warranty. And we have solution for the submerged zone, such as boat landing, jacket lake, hull fender, jetty lakes, and pores. Now, these are areas that are completely submerged and you can still paint in the submerged area. All of these three areas now allow us to explore the possibility of simpler surface preparation and in certain cases, even lower thickness. Very specifically for splash zone and submerged zone, these two systems that we have developed today is suited for marine applications as well. And our most recent release is what we call the rust converter, a variation of ProShield Plus. It's otherwise termed as neutral. This is our rust converter and it's designed for a quick fix. Typically, if you look at a conventional rust converter today, you would have a quick fix solution that has either zero warranty or limited warranty, and it would require a minimum ST3 or ST2 surface preparation. And you would definitely need to apply another layer on top for corrosion protection. With our enhanced rust converter that we have developed with Kossan paint, all you need is at minimum wire brushing. And because it has very good adhesion properties, at the same time it creates those barriers, today we're able to see also extended service life up to 3 years. And can also be applied using drones for hard to reach locations. Now, we are also able to evaluate the possibility of providing warranty between 3 to 5 years for this particular solution that we have. Now, one of the best things about doing this within Petronas is that we have quite a number of assets that we are able to roll out and see real life data. So the minute it graduated past the proof of concept, we went into pilot scale application and commercial application across our assets, all the way up in the Northern Peninsula side, right down to our Borneo region, upstream and downstream. Some of the areas that we have assessed and applied would be in our platforms. Sorry, Terence, do let me know if there are questions coming in. Otherwise, I'm just going to continue.
You're good.
Okay. We've also applied it in our marine ships, FSOs. We've applied it in our downstream plant, a part of the maintenance projects. We have it in our some of our utility plants in the East Coast region. We have applied it in the Navy side, a jet fuel V tank as well, also performing very, very well today. And all of these are the assets that we have today deployed. And it's been more than a year since its deployment. And one of the initial findings that we have after, well, today would be 2 years in, when we go back and we check on the performance of the paint, there's been no degradation of the coating found. And all of these were done using simpler surface prep. And as for the rust converter, the most recent one that we have rolled out. Now, if you can see visually, this is how it looks like. When we painted 6 months ago, this is a non-graphene paint, and this is the paint with graphene. 6 months in our East Coast offshore platform, you can very clearly see the visible difference between the graphene coated and the non-graphene coated rust converter. And what was evident when we looked at the field trial tests is that we saw 40% lower corrosion creepage. And today, what I can summarize is within Petronas Advanced Materials, we have a range of solutions. We're able to provide the market the quick fixes that behaves better than your conventional system, such as a rust converter. And at the same time, we're able to come up with variation of long-term solutions that is designed to extend the service life by 2 times to 3 times. And this comes in the form of standard tolerance epoxy as well as gloves plate epoxy. And this is where we work with paint manufacturers, the likes of Kossan Paint, who's with us as our partner, who continues to develop this paint so that it can enter the market and it can provide better value to the asset users. Now, with that said, I'm going to pass the floor to Mr. Keys from Transocean to walk the group through what the technical performance has been from his observation. Over to you, Keys.
So what I will do is I will do a brief introduction of Transocean, and then I bring you up to speed with what we have done with graphene in protective coatings. I must also just a brief that we have done because it's a lot of data that we have, but given the time, it's brought down to the very basic points of it. And then also I will explain to a conclusion and the way forward. So Transocean itself, we are an association active since, we are an active since in the market since 1959. And we are focusing, our brand is focusing on marine paints, protective coatings and offshore coatings. So we have a presence in pretty much worldwide with 22 factories with activities over 60 countries. We have a central office and lab in the Netherlands. And if you do a next tab, Terence, you see in Malaysia, we are working with Kossan Paint, and Kossan Paint is the technology partner of Petronas for the ProShield development. A brief on the product range. Basically, we cover the wide range of type of products and which are approved by class for the marine market, and approved for the protective coatings market by several institutional companies. And some of them, you see the logos on this slide. So that is the brief introduction. Let's go to the main topic, and that is the use of graphene materials in protective coatings as done by Transocean Coatings. So our approach was that, okay, let's start and do an initial start in several epoxy systems. From there, we saw some influences, we get test results, and we had a two-way approach. One is that we say we increase the scope of testing, and that I will show you in the next slides. And then also we start at the same time with field testing in collaboration with Kossan Paint. Then finally, we end up with the validation of the test results, the follow-up, and the commercialization of products. So Serum is an independent testing lab in Malaysia. And what they do is they are testing paint systems of various paint companies to the Petronas paint specifications. And what we have done is we were, as Transocean, we were already approved by Petronas with several paint systems. So we have compared the performance of our paint systems with and without graphene. And the findings were interesting because although we see that on the performance testing, we see a positive effect, but we cannot really say it was conclusive. And maybe that's the existing paints were already very good, of course. But we did see the increase in adhesion values by 10 to 30%, dependent on the system. So that was the serum testing. We also did the testing in Netherlands, if you go to the next, and that was by the testing company CCT Pro. And there we did more stringent testing. We tested against the ISO 12944 / the NORSOC M501. And we tested the cyclic corrosion test for 4,200 hours. We did the seawater immersion testing and also the cathodic disbonding testing, all 4,200 hours. And what we saw is something interesting because we had two types of high build epoxies, and we tested it at a one-coat system and a two-coat system. And normally the specification to ISO or NORSOC, it would call for a two-coat system. But finally, we saw is that in one of the epoxy system, we really see a positive influence on the creep performance, on the cyclic corrosion, the immersion testing, as well as the cathodic disbonding. And the fact is that on the other epoxy, we did not saw that influence, or it was not conclusive. So that was a quite interesting finding. Going to then from the next point, so what we did is, because of the good results we had, we already start with doing the test application in practice in collaboration with Kossan Paint. But also we try to understand why we see a difference in the results. So we discussed with the industry, amongst Terence also from Graphene Council. We also thought, okay, the dosage form of graphene may have an influence, but also the dosage percentage itself. Because what we also saw is that sometimes you can maybe use too much. And then what you see is the flakes are layered on top of each other, and you do not get that nice laminar effect, which is giving the good barrier against water penetration. So that made us think that, okay, the doses is maybe also important. And I don't know who, someone also said to me, if it doesn't work, use less. The other point is also the method of incorporation. While discussing with people in the field, and I think it was the University of Manchester, they also communicated to us that the method of incorporation, the graphene, is important. And what you see here is two images from a SAM picture, where on the left we have the method of incorporation number 1 and another one. And you can clearly see that on the left, the distribution of the carbon, that is all the blue, that is a much finer than in the method 2, where you see more coarse distribution of the graphene. Our goal is now in the follow-up testing that we are trying to link those, what we see in the characterization of the film, with the performance testing. So what is now ongoing is to see, okay, we know the distribution of the graphene in the paint, and what is the end result with the performance testing. And well, we have already done the pull-off adhesion testing. Basically there we see, yeah, everything is okay, very good results. Also the electrical impedance spectroscopy has been done. Also there we see, yeah, the excellent to very good results. But now it's waiting for the performance testing to see, okay, can we link the difference in loading and method of operation, can we link that to the performance testing? And of course, it is important to understand, because that is also important for the final production of your paint. Meanwhile, while doing this, we are also doing field trials with commercially available products in Malaysia through Kossan Paint. And these paints are the Transpoxy Masterbond Pro, which is a surface-tolerant epoxy based with the graphene, and it has been approved by the Petronas systems N1, N8, and the maintenance system N1. We also have the Transpoxy ST epoxy approved. That is using the graphene-based rust converter variation. And there we have approvals for the maintenance specifications M1, N7, and M8. So currently all those trials are now in progress, and yeah, we are anxious to see the results in practice, as well as, of course, to see the results of the performance testing. So as a summary, I think we can conclude that graphene in protective coatings, it can enhance performance, but we also still trying to see, okay, what is the type of paint formulation that is the right one? And also we try to widen the type of paint formulations, like for instance, going towards chemical resistant coatings. And there is also more knowledge is necessary in terms of the method of incorporation, the supply form, and also the dosage. And I think also all of that is also related with the quality control of the final production. If that distribution of the graphene in your paint is important, how are we going to check that in the production, but also in the field? And that is also where maybe, the Graphene Council can play a role. So with that said, I would like to thank also Kossan Paint Research and Development Center for all their support, and Petronas too, and Terence for organizing the seminar. Thank you.
Thank you very much, Kees. Really appreciate that, and I appreciate all of both of the presentations. Very informative. I think there's an observation that I'll make from my side, and then we'll go to questions and answers. And if anybody has any questions for any of the presenters or the experts on the panel, please use the Q&A dialog box to write your question. You know, as the Graphene Council, we've been involved working with graphene and graphene enhanced systems now for more than a decade. And we've seen the evolution of this sector go from a lot of R&D and development to where it's become a mature industrial product. And the example that you see here, especially with Petronas, with the field trials and the application on actual assets and infrastructure, and not only that, but to be able to have measurable difference in results is quite significant. The other observation I'll make, and Kees, I might look to you to make a comment on this. You know, in the arena where you're dealing with the marine environment, and here we talk about fixed assets like drilling rigs and this kind of infrastructure, but this also obviously applies to ships. And when a ship is in dock for repainting and for maintenance, it's not earning revenue. So that's a huge, huge financial impact to be able to extend the life either of a floating asset that's earning revenue, or for the fixed assets and the maintenance costs to maintain and protect these extremely expensive pieces of infrastructure. So the good news is that this is an actual product that's actually available, it's being used, and it's demonstrated success in live environments, and not once, not twice, but I think there were about a dozen sites that Petronas had shown, and where you have field trials in the most harsh environment you can think of, and that would be offshore assets. So those are just some observations from my perspective. So one of the questions that comes, what is the situation regarding IP protection of these graphene enhanced paint formulations? Are these patented, et cetera? So I think that's an interesting question, because there are different partners involved in this. You have graphene producers and suppliers, you have formulation, and then you have paint companies as also important stakeholders in this. So I'm not sure who would like to take this question, but let's talk about the intellectual property protection for these unique formulations.
Yeah, I can go ahead. Have a go at this, Terence. For Petronas, the recipe sometimes is patented or it remains as a trade secret. It really is an option that we will evaluate what would be the best method going forward. If there is a unique approach to how we create the recipes, more often than not, we would use the trade secret part.
And we see that, again, just to echo that, because as the Graphene Council and the Advanced Carbon Council, we don't work with just the producers of graphene, but we work with the companies that actually apply and use this. And I can echo that a lot of companies choose the trade secret route to protect their intellectual property when it comes to using graphene. So they keep the formulation secret, the amount, the load factor, all of those details, which make a huge difference in the effectiveness of the end application. And I think personally, the trade secret route is actually quite a clever way to go. There's another question here. How much does the performance of the paint depend or vary with different graphene suppliers? And there are quite a large, let's say, there's a lot of flavors of graphene available in the market based on platelet size, layer count, chemical composition, whether it's functionalized, et cetera. So how much does that impact the results? And Dilly, I'm going to look to you to answer that, if anybody else wants to jump in.
I think this will be best answered by our lead R&D, Dr. Samsu. Dr. Samsu, do you want to take a crack at this?
Okay, all right. If you want to talk about the performance of the several types of graphene, different in terms of the morphology, different lateral size. Different morphology will give a different kind of the performance, especially for the barrier and also for the corrosion resistance.
On my side, it seemed to hesitate. I'm not sure if it hesitated on everybody else's side.
It did.
Okay. So just to recap, if I understood correctly, the morphology of the graphene particles does impact the performance dramatically. So it's simply a case of finding the right graphene for the particular application and for the host matrix. And Samsul,
Absolutely, Terence.
Yeah,
Absolutely. If I can just expand from what Dr. Samsul has mentioned, the morphology matters, and there's a base criteria to the type of graphene that qualifies for different segments. But that said, there's still that process that the team does, which includes modifying that existing graphene that passes the base criteria either mechanically or chemically, so that it gives that enhanced performance. So there is still that bit of enhancements done within that chain of getting towards that final recipe that works. But in any case, whether it's coating, battery, or composite, there's already a base spec for a certain type of morphology of or criteria for graphene to pass through, so that there's minimum modification required.
excellent. We have another question that's very closely related, and that is, have you observed any effect on barrier to corrosion related to the lateral dimension of the graphene? So graphene flakes could be sub 1 micron, they could be 10 micron across. There's quite a variance in the lateral size or the platelet size. Does anybody want to respond to that question?
yeah, if I can answer this question, basically, lateral size play a role in improving the barrier properties or the corrosion resistance, and it also depends on the base resin, because certain type of supplier using different type of pigment, so we need to tailor our graphene morphology according to the pigment size from the different paint manufacturer.
Excellent, thank you. And just a note, we do maintain an internal database at the Graphene Council, the Advanced Carbon Council. We've now cataloged more than 700 specific different versions of graphene that are commercially available. And so we do monitor and track that. One question that always comes up, and that has to do with the financial aspect of this, is, how high are the graphene prices estimated in order for corrosion protection to still be competitive? We've had a number of presentations on this aspect. And first of all, I'm going to just give an observation from my side, and then I'd like to ask both Kees and Dilly on this. One, the perception that graphene is prohibitively expensive is a sticky perception. It's also an incorrect perception. Graphene today is very competitively priced. And I would say in many cases, it's less expensive than other long-standing additives that are often used to enhance products. So the price should not be a barrier to the adoption and use of graphene. Secondly, graphene is very effective when used in extremely small fractions or load factors. And that, of course, impacts the financial impact because you're not using a lot on a per unit basis. So we cannot discuss prices here, but I will tell you that prices vary pretty broadly, and they're very much volume dependent. But there's absolutely no reason that price should be a barrier to using graphene in these systems. And so, Kees, I mean, you see a lot of different additives used in paints for these kind of applications. Do you have an opinion on this? And hopefully it's a similar one to what I just shared. I'm not sure what your view is. Sorry. Well, if you get the sound back, then we'll pop that back in. I don't know, Dilly, do you want to discuss this? The price, price performance.
Yes, of course. My view is absolutely on point with yours, Terence. The price of graphene is no longer as exorbitant or as unregulated as it used to be even 3 years ago. The other thing we have come to realize as we went on to deploy this commercially is that the coating space, it is in that ultra low load factor. It's a very tiny bit of graphene required for that enhanced performance. Now, going a step further, in any system that you paint, it's going to be either 2 layers or 3 layers. And graphene just takes up one of the 3 layers. So when you look at it from a system angle, the price variance is almost, it's too small. Perhaps you're going to look at a fluctuation of 10% to 20%. But then, if you take a step even further and look at the complete cost to apply, because it's not just the system cost, it's also the application cost that matters. And application is 90% of the total cost of painting. And when your application cost becomes a lot more effective and productive, at a net value, you would see savings. So it's important that when we look at graphene, we don't look at it from a component angle, but rather all the way up to a system angle and onwards to the application. Because the net saving to an end asset owner is truly in the application space. And not to mention the life cycle cost. If you're building to own and operate, you're going to see a huge savings there. I would pass the baton back to Mr. Locke as well, who's a paint manufacturer selling this, to see if he would like to weigh in. Over to you,
So
Mr. Locke.
basically, from what we can see is that the incremental price for coating system-wise is very, very minimal. Like what Dilly was saying, around 20 over 30%. That's the most. But eventually, if you're looking at the space of application and the scaffolding costs, there will be very, very significant reduction in terms of the performance for duration. So because if normal painting system, we can give you around probably 3 to 5 years kind of performance warranties. And then with graphene, you can easily go 10 or beyond that. So the cost saving can be covered back from the duration of the performance later on.
And if you don't mind, I'd like to ask Mr. Locke, I'll ask you a question. And I think this is one that often is asked, why would a paint manufacturer want to have a paint that lasts 10 years instead of 3 years, right? Because in one way, you're reducing the market for your product. Can you talk about that a little bit?
What we are looking at, because what we're handling is the pain point of the, especially for the asset owner like the oil and gas, Petronas, Shell, we just mentioned it. The cost of repainting and maintenance of their painting structures is tremendously high. So if it doesn't address it, at the moment, there's nobody going to address this issue for them. If we didn't stand up and address the issue, and the issue will be persistent, continuous to be like this throughout the whole life. So we will. That's why when Petronas approach us to do with these products, we feel that this is something that is worth doing it.
Thank you for that. I see this as an opportunity because the paint market is obviously very competitive. And I would imagine, at least this is my observation, this is a great way for companies to innovate and to differentiate against the rest of the field with a product that's really, truly superior in performance. Kees, do we have you back on sound? No, sorry. All right, well, we'll keep working on that. And we'll have you come in. Maybe you can write some answers if we can't get you on sound. There was a question about how graphene is made. We have tons of information about that on our YouTube channel, and I'll answer that separately. So there are some questions about what's the range of best performing, the loadings that work the best. I mean, these are the trade secrets, obviously, that we're not going to share here, or Petronas is not going to share here, which is understandable, hopefully. And we just talked a little bit about the economics. So I'm going to go to a next question, and that asks about wear resistance and impact resistance on these coatings. It wasn't in the data that was presented, but I don't know if you have any data on the physical, abrasion resistance or wear resistance, the toughness of these coatings. Does anybody have any comment on that?
You want to take this on, Dr. Samsul?
Okay, talk about the wear resistance of the coating by introducing this graphene. Based on our work that we have tested in our lab, in terms of the improvement for the wear resistance is around 50%. It is based on the table abrasive test. If we familiar with coating table abrasive test after 1000 cycle with a 1 kg load, in terms of the improvement, we can reduce in terms of the weight loss of the coating with 50% of improvement, basically.
A 50% improvement in wear resistance.
Yeah,
That's amazing.
Yeah, because we know that graphene has a feature of lubrication, so it can improve or reduce the friction between the two contact surface.
Excellent. So a 50% improvement in wear resistance. And I think, Dilly, from your presentation, you talked about a 2 times life extension of the coating, which is enormous, right? And again, it's already been mentioned, the cost of actually applying or taking a product or an asset down out of service while you're doing the maintenance work is hugely expensive. So to be able to extend that life is tremendously valuable. There is a question, and I think you may be able to speak to this, about whether or not the graphene has been modified or the term of art is functionalized, if it's been chemically altered and stuff. Is that something you feel comfortable you can talk to a little bit about how the graphene is modified, or if it has been modified, or because I know
I think,
might
yeah.
cover trade
Well,
secret.
we'll keep it general, but yes, the graphene has been modified. Some just at mechanical level, and certain few has gone all the way up to the chemical level.
Excellent. There is a question about how graphene is made and sustainable sources, and we do know that there's graphene that can be made from methane gas as a process, from biochar and biomass material, from graphite. There's many different ways, and looking at the sustainability of graphene production is a project that actually we're working on at the moment, and calculating the LCA, the carbon footprint of graphene production. So I would just say stay tuned with us, as we'll have more information at that. Another question, we have lots of questions, so I appreciate this. There's a lot of interest here. What about temperature range and performance, and in particular at high temperature? Do you have any experience or feedback about that, any of our presenters?
Okay, if I can share in terms of the temperature, the stability, we know that in terms of the graphene, in terms of the thermal decomposition, it can go up to 600 degrees Celsius. But when we add in graphene into this pin or coating system, the thermal stability is depend on the base resin itself. Especially for the epoxy, some of the supplier claim that it can go up to 120 degrees Celsius. So the performance of the graphene or the performance of the coating will not much affected by the graphene, because the addition of graphene is very small amount. So we didn't see any effect of graphene in improving in terms of the thermal stability, because the loading is very small. Unless we add in too much, maybe it can give us different effect to the paint system.
Okay, so there was neither a significant improvement nor reduction in performance from a thermal. Yeah. Okay.
Yeah.
Excellent. Well, there are quite a few questions. There's questions if there are any systems where graphene was not compatible. I'm not sure if that kind of testing has been done. But I would say this, from our observation, having seen so many different applications and using graphene and epoxies, graphene seems to be quite compatible across a very broad range of materials, whether it's a thermoplastic or polymers or epoxies. I can't really imagine that there's a system that graphene is not potentially suitable for, especially because you can alter the type of graphene and also the functionalization of it to tune it to the host material. One of the questions is on the application of this product potentially on the inside of pipelines. So if you think of the quite corrosive environments in a petrochemical plant or in just a chemical plant, does anybody want to discuss the potential use of this application as the lining on the inside of pipes? Is that a potential application?
Okay, at this moment, in terms of the application for the lining or for the chemical resistance, we have not yet tested in our lab. But based on the journal or any article published in the internet, there is study that can show graphene can improve in terms of the chemical resistance of the paint, of the coating. Maybe from Transocean or Kossan side, want to comment further?
We are planning to explore the plant lining this year for the painting systems.
I'm aware in the marketplace, I know that pipeline lining for a chemical plant is an application that has been used. So, and there's no reason to believe that it wouldn't that wouldn't be a suitable application because of its barrier properties. That's quite a logical application.
Our applications have so far been for the external surfaces, Terence, and it's largely because we haven't really covered most of the assets and coating for the external surfaces. But corrosion under insulation is also one of the biggest asks from the downstream plants, as well as internal pipeline linings as well, which is what we're working together with Kossan to achieve next.
Excellent. There is another question about the scalability of this and how easy it is to use this on a very large scale, on an industrial scale. Look, I would ask you to describe this. You're looking at this as a paint manufacturer and supplier. Obviously, if this is successful, you'd want to use it on a large scale. Do you have a comment about the scalability of this?
So basically, scalability is not an issue for paint industries. So for us, even for Transocean perspective-wise, we have 20 factories around the world that can supply more than 90 countries around the world. So I think it's more than enough to cover the whole world at the moment.
And we also know that, graphene itself is not in short supply. We have an ample supply of graphene. There's a number of graphene suppliers, so it's not like it's from a single source. You have options for that. It's priced competitively. And obviously from this presentation and from the information that's been delivered, the understanding of how to apply this and formulate it has been solved. So there's no barrier to commercial adoption on a large scale at this point, which is really important. And again, I would emphasize for those on this call who are asset owners and who have an interest in reducing the total cost of ownership, that this is a commercially available solution today. There's a technical question about, has there been any change in the electrical conductivity in the coating, if that's been measured?
I think, Dr. Samsu, maybe you can shed some light on the conductivity, electrical conductivity. I think from our understanding is the load factor is so small that this is not at all affecting the system in any way. But I'll pass the baton to Dr. Samsu to just reascertain that.
Okay, in terms of the conductivity, because we have tested the coating with graphene using EIS, electrochemical impedance spectroscopy, where it's based on the conductivity of the paint. So based on the study, we can see the coating with graphene not produce any conductivity, but in fact, it will give kind of the barrier to slow down the penetration of the electrolyte to the substrate from the coating. The conductivity is only happen when we add the graphene based on literature is more than 5% of graphene. If the graphene loading is too high, yes, it can conduct the conductivity to the paint.
Thank you for that answer. I know in the past that some paint manufacturers or formulators were quite concerned about putting graphene into the paint formulation because graphene, of course, is famously very highly electrically conductive. And so it was anathema. They couldn't imagine, why would I put this electrically conductive material into my paint that would cause this potential corrosion potential. And the fact is that when graphene is loaded, it has to be at a very high percentage to get electrical percolation. That's one. Also, there are forms of graphene, like graphene oxide, that are not electrically conductive because of the oxygen groups in them. So that also has potentially an impact if you're using that type of graphene. So long story short, yes, graphene is highly electrically conductive. No, it does not make paint electrically conductive unless you're loading it at levels that you would never use, because then you start to lose the barrier properties when you're percolating it at such a high level. There is a question about using graphene on radar or radio frequency reflective paints, for example, for warships. I think that's another topic, unless our panelists want to address that. but there has been a lot of work that's been done on EMI shielding and on radar absorption. And we do know that many departments of defense have a tremendous interest in graphene because of its potential dual use applications. That's not really in the scope of today's presentation. And I invite you to reach out to us at the Advanced Carbons Council to discuss this. But if anybody does have a comment on that, I'm happy for our presenters to make a comment. We'll leave that one alone. We'll leave that one alone. So I think, we've had another question about, the inside of pipeline. There's a lot of interest in using graphene in hydrogen. There's one of the last questions we have there is specifically about hydrogen embrittlement. And we are running at this time as the Advanced Carbon Council and the Graphene Council, we are running actually a hydrogen permeation test application. In this case, it happens to be with graphene in a PA11 thermoplastic as a liner for hydrogen pressure vessels. But this is just another example where it's quite interesting about using graphene for barrier properties, and especially against a molecule as small as hydrogen is amazing. As we conclude today's webinar, I want to say a huge thank you to Transocean for being part of this, because I know you guys are experts at the technical specification and you're a very objective, independent third-party evaluator of the technical performance of these materials. And we're very excited to see, the test results proven there. I want to give a huge thanks to Petronas for sharing the data on the application of this enhanced coating system on your live assets, which is not a trivial thing. And I think it's really important for anybody who's contemplating using these graphene enhanced coating systems to understand that these are being used on really valuable, important assets, and not one or two or three test cases, but quite pervasively throughout. And I also want to thank Kossan Paints for the work that you're doing. I think it just shows the partnership between an asset owner and a paint supplier, and that you've created this formulation and you have this commercially available today if customers want to take advantage of this. And I'll leave the last word to our panelists if there's any closing comments you want to make. But thank you to everybody who's participated so far.
I think you've eloquently summed it all up, Terence. Nothing further from us. And to the members who have joined in, participants, if you have any questions at all, how this paint works, and if you would like to even access it, do reach out to us. Us from Petronas Advanced Materials, Mr. Locke from Kossan Paint, and Keys from Transocean. Any one of the three parties will be more than happy to walk you through the journey and see how we can bring this to a wider market beyond just Malaysia and beyond just Petronas assets.
Well, thank you, everyone. And again, the closing word is this is available today. It's a real world application. So please reach out and take advantage of this. The waiting is over. Have a great day. Everybody have a fantastic day. Take care.
Thank you. Thanks.
Bye.
Thank you, everyone. Bye.